Every single time you make an API call to a closed AI model, you're actively sending your proprietary data to someone else's server. Your sensitive prompts, your code base, your customer data, it's literally leaving your perimeter. And from that moment on, you have absolutely zero visibility into what actually happens to it. If you're a CTO, a security engineer, or an AI architect, this isn't just some hypothetical privacy concern anymore. It's a critical structural security bottleneck. So today, we're going to break down exactly why this closed architecture is failing under pressure, and more importantly, how we can fix it.
To help us navigate this, we'll be looking at the data exposure problem, vendor lock-in security risks, the compliance nightmare, the open weight alternative, and finally, finding a middle ground with hybrid architecture.
So, what actually happens when your AI refuses to investigate a breach? Well, let's look at a visceral, real-world incident from July 2026. Picture this. Hugging Face, a massive central hub in the AI world, gets breached. An autonomous AI agent, specifically a pre-release version of OpenAI's GPT 5.6 cell, managed to breach their systems through a zero-day vulnerability in a package registry proxy. But honestly, the breach itself wasn't even the most shocking part. The real wake-up call was what happened when Hugging Face's own security team tried to investigate it.
Their security disclosure perfectly captures the nightmare they faced. They realized the commercial APIs they were relying on for their defense were actively working against them. When their incident responders tried to feed the attacker's logs, the exploit commands, and the command and control artifacts into closed, hosted AI models for analysis, the API flat-out refused to process them. You see, the safety guardrails of those commercial models simply couldn't tell the difference between a security professional analyzing a live exploit and a malicious hacker trying to generate one.
Right, let's move into our first point, the data exposure problem and the huge risks of putting sensitive data into third-party infrastructure.
Security professionals are starting to call this the asymmetry problem, and it makes total sense when you look at the contrast here. Attackers are out there operating with unrestricted, often open-source models. They're executing thousands of tasks at machine speed with absolutely zero guardrails. But meanwhile, defenders, they're severely handicapped. We're relying on commercial safety filters that are really designed for the average consumer API. So if you're an enterprise defender, your AI tools are essentially blocked by their own safety mechanisms, while the attackers just get to run completely free.
The absolute crux of the issue here is the massive difference in data flow during a crisis. With a closed API architecture, your most sensitive data, we're talking active exploit payloads, network topology, captured credentials, trade secrets, all of that has to leave your perimeter and go into a third-party black box for analysis. During a live incident, that is just an unacceptable exposure risk. On the flip side, a self-hosted model ensures your data stays entirely local. You get full visibility, and your incident responders can run unconstrained analysis without some external safety filter shutting them down.
Which brings us to part 2, vendor lock-in security risks and exactly what happens when the API fails you.
We really have to ask ourselves a pretty uncomfortable question here. What happens to your cyber defense capabilities when your API provider decides to change its model weights overnight? Or what if they have a massive regional outage? Even worse, what if the provider gets breached themselves? Because if your incident response stack is completely outsourced to a closed API, well, you've outsourced your operational resilience too. You are effectively trusting your company's survival to a third party's uptime and policy decisions.
Next up is our third section, the compliance nightmare and the sheer impossibility of auditing a black box. Relying on closed APIs makes passing rigorous SOC 2, HIPAA, and GDPR audits incredibly complex, if not basically impossible, when you're handling highly sensitive artifacts. And the reason is simple. You cannot audit a black box. You have zero visibility into their indexing controls, and their log retention policies are totally unverifiable. I mean, think back to that major privacy incident in July 2026, where seemingly private user conversations with Anthropic's Claude AI just suddenly started showing up in Google search results. When you see systemic risks like that in chatbot data handling, it becomes painfully obvious that routing regulated enterprise data through public APIs is just a compliance disaster waiting to happen. Thankfully, there's a solution. Let's talk about Section 4, the open weight alternative, and how we can eliminate the middleman.
Let's jump back to that Hugging Face incident for a second. How did they actually solve their problem when the commercial APIs locked them out? Well, they pivoted. They managed to resolve the crisis by deploying GLM 5.2, which is a highly capable open weight model, and running it entirely on their own internal infrastructure. This specific move literally saved Hugging Face. It proved beyond a shadow of a doubt that keeping your attacker data, active payloads, and sensitive credentials tightly circulating within your own sovereign perimeter is the absolute only reliable way to do unconstrained security analysis.
And to really wrap your head around the scale of this revolution and just how far open-weight models have come, check out this number. 2.8 trillion. That is the parameter count of the newly released open-weight model from Moonshot AI, Kimi K3. We're not talking about small, underpowered local models anymore. We are dealing with massive, frontier-class intelligence that is available for you to download and control completely.
Now, let's be super realistic about what it actually takes to run something of this magnitude. Self-hosting frontier intelligence, like Kimi K3, requires serious hardware. You're looking at 1.4 terabytes just for the weights, which means you need a cluster of 64 or more enterprise-grade accelerators. It's heavy, but for organizations that need absolute security, that trade-off is absolutely worth it. It gives you full air-gapped capabilities. It totally eliminates the API middleman. You have zero inference cost lock-in, and most importantly, it's fully auditable for your security and compliance teams. When you own the infrastructure, you own your security posture.
Finally, we arrive at Section 5, the hybrid architecture middle ground. This is a practical blueprint that most CTOs and architects should probably adopt today.
So here is the decision framework you'll want to implement. It's not about just picking one approach. It's about routing to the right tool for the job. You can still use closed APIs like GPT 5.6 or Claude 5 for your hardest reasoning and complex coding tasks, places where data exposure risk is super low. Then use hosted open models for high-volume, routine work so you can save on costs. But, and this is the critical takeaway here, you absolutely must use sovereign, air-gapped, self-hosted models for incident response, cyber defense, and literally any workload that involves highly sensitive regulated data. Okay, so how do you actually build this out? First off, you need to separate your application workflow from your model selection. Do not hard-code a specific provider. Second, implement a unified API routing layer. Platforms like Eden AI are great for this. By doing this, you abstract the model away from the workflow, which gives you automatic failover and completely eliminates your dependency on any single vendor. And lastly, and this is arguably the most important step for your security, maintain warm, ready-to-go, on-premise fallback models. That way, if an attack happens or an API goes down, you can seamlessly route your security workflows right back to your local infrastructure without missing a single beat. I want to leave you with this final critical thought to help you evaluate your own enterprise architecture right now. Hopefully before the next zero-day attack happens. When the alarms are ringing and you're staring down an active breach, does your AI actually work for you, or is it bound by the rules of its provider? You need to ensure you have the right architecture in place so that the answer is always you.